This presentation is on rock filters, which are used to polish the effluents from waste stabilisation ponds. In the European Union, wastewater discharges are governed by the Urban Wastewater Treatment Directive. This table is taken from the directive, and it states that effluents from wastewater treatment plants should have a BOD no greater than 25 mg per litre. But for pond effluents, this is filtered BOD, that is to say, excluding the BOD of the algal solids in the effluent. The directive also stipulates a maximum suspended solids concentration in pond effluents of 150 mg per litre. However, environmental regulators in member states are able to apply stricter effluent quality requirements. So, if the Environment Agency in England and Wales or the Scottish Environmental Protection Agency requires better than 25 mg filtered BOD per litre and or 150 mg suspended solids per litre, then it would be a good idea to treat the wastewater first in a facultative pond and follow this with a rock filter. This slide shows a pond and rock filter system at a small town called Veneta in the state of Oregon in the western USA. The wastewater is treated in a facultative pond and then in a maturation pond, and the effluent from the maturation pond goes through the rock filter, which in this case has been constructed in a corner of the facultative pond, although of course it's a completely separate unit. The results showed that this rock filter is very good indeed at removing suspended solids, as you can see in the slide. The gold plot is for the pond effluent, that is to say, the rock filter influent, and the white plot is for the rock filter effluent. But, of course, the performance of the rock filter depends on the loading applied on it. In this graph, the percentage suspended solids removal is plotted against the hydraulic loading rate, or HLR, on the rock filter. This is the volume of pond effluent in cubic metres applied to the gross rock filter volume, also in cubic metres, per day. So the HLR has units of cubic metres per cubic metre per day, or just days to the -1. The slide shows the equation for suspended solids removal as a function of the hydraulic loading rate, and there is also the corresponding equation for percentage BOD removal. Rock filters soon become anoxic, so there's no removal of ammonia by nitrification. Here at Leeds, we wondered, if we aerated the rock filter, would we get nitrification? A final year undergraduate student here in Leeds did his project work on this a few years ago, and he found that aerated rock filters worked very well at lab scale. So we then set up a pilot scale system at Yorkshire Water's wastewater treatment plant at Esholt in Bradford. This comprised 3 filters, an aerated filter, an unaerated filter, and a planted filter, in this case planted with typha or bulrush, so it was really a constructed wetland. The units were identical in size and they were fed facultative pond effluent rather than maturation pond effluent as in the USA. They were all subsurface horizontal flow reactors loaded at the same hydraulic loading rate with a wastewater depth of 50 centimetres. The aerated filter was supplied with air from a compressor at the rate of 20 litres per minute. The results in summer were excellent. Less than 2 mg of ammonia nitrogen per litre of the aerated rock filter effluent, and around 7 mg of nitrogen per litre for the unaerated filter. The planted filter did quite well, achieving around 4 mg of nitrogen per litre. But in winter, the planted filter was almost as bad as the unaerated filter, whereas the effluent from the aerated filter was still below 2 mg of nitrogen per litre. This chart shows the percentage removal of suspended solids. The red line is for the aerated filter and it clearly performed much better and more consistently than the other two. And this chart shows that this was also the case for BOD removal. When we come to ammonia removal, the aerated filter was best again, although in high summer the planted filter performed just as well, or even slightly better. And we know that nitrification occurred in the aerated rock filter because there was plenty of nitrate in its effluent. The aerated filter also removed fecal coliforms extremely well, even in winter. The mean effluent fecal coliform count was below 1,000 per 100 ml throughout the year, and below 100 per 100 ml in summer. So rock filters can successfully replace maturation ponds, and this leads to a significant saving in land area requirements, just over 1 square metre per person for a rock filter, whether aerated or not, and this compares more than favourably with the 5 square metres per person for maturation ponds in France. So you can treat the wastewater from small rural communities here in the UK or elsewhere, for example in Europe or New Zealand, with just algae, rocks and, if you have to remove ammonia, with air.